So we're going to look at problem 12 on our review activity. And it says, at what pressure is the mean free path of air approximately 1 meter? So in class when we talked about gases, we gave this complete formula for the mean free path, right? We said it goes as 1 over the square root of 2 times pi times the collisional diameter of our molecules times the concentration of molecules per volume. And then we also gave this relationship for the molecular concentration via the Avogadro's number. So Avogadro's number is the molecules per mole, and N over V, right, is the moles per volume. So then that gives us a molecular concentration, molecules per volume. That N over V we can get from the ideal gas law. N over V equals P over RT. And so this is a combination of factors then that gives us our molecular concentration in the denominator here. What this means then is that the mean free path is proportional to temperature and inversely proportional to pressure. And if we're looking at the same gas then at two different sets of conditions, then we don't necessarily need to use this complete formula for the mean free path. Instead, we can just say that the mean free path at one set of conditions divided by the mean free path at a second set of conditions is the ratio of those two conditions. So a direct ratio of the temperatures and an indirect or inverse ratio of the pressures. And since in this case we don't see anything about temperature changing, only pressure, then the ratio of temperatures can equal 1, and we can use our mean free path of air at standard conditions, or in this case just standard pressure, to calculate our mean free path at non-standard conditions. So standard pressure is about 101,000 pascals, and we're interested then, actually in this case we have our lambda 2. So lambda 2 should be 1 times 10 to the 6 microns, right, 1 meter. And we want the pressure then that's associated with that. So rather than solving for the conditions, or rather than solving for the mean free path, we're solving for the associated conditions. So then P2 equals the mean free path at standard conditions divided by this much larger mean free path. And that means then that we're going to require a much lower pressure, right? 0.0067 pascals in order to get that much larger mean free path.